Hello, my name's Kevin Large and I'll be your instructor for today's video. Welcome to the fifth in a series of videos in which we're building a network using Cisco's packet tracer, which gets more and more involved and more complex as we move from video to video. This video will cover basic security. As this is the fifth video in the series, I'm going to start moving through things just a little bit quicker, and in this video we're going to cover quite a lot of ground. We're going to look at usernames and passwords, setting a minimum password length. We're going to look at privilege levels. We're going to configure the service password encryption command, which will encrypt any passwords that are not already encrypted on the system. It's a fairly low level of encryption, and we'll prove that as well, but it stops people looking over your shoulder and looking at your password when you're doing a show running config. We'll configure an idle timeout. We'll configure login blocking, a very useful feature, very good to protect against brute force and dictionary attacks, and we'll create a banner. Banners are very useful to have for legal purposes, if nothing else. We'll configure Telnet access. Now that's, as it says in brackets, not a very good idea because Telnet's clear text. And we will configure SSH access, much better because it uses very strong encryption. And finally we'll configure switchport port security. Okay, so we're going to move on to our network. It's precisely the same network that we've been working on all the way along. And now we'll come into video 5, the security video. We need to make sure this network is secure, because currently there are no passwords on pretty much any of the devices on the network. The only exception to that being the wireless access point, which does have a passphrase set up for WPA2. So all the switches and all the routers, very insecure at the moment. So the first thing we're going to look at passwords. Now obviously there are certain things you want to make sure you do with passwords. They should be complex. They should combine letters, uppercase and lowercase, numbers, special characters or symbols, and the password should not use dictionary words. And finally, you should make sure you change your password as often as possible, within reason. Okay, so let's have a little look. We'll go into the router first. We'll go into our corporate router, our company's edge router, and you can see that if I hit enter, I get straight in. I get into what's known as user exec mode. Now there's not a lot you can do in that mode, but if we use the question mark, you can see we can do a reasonable number of things. Let's have a little look. We've got show commands. So what can we show? We can show the clock. The clock is not set correctly at the moment, but we'll set up NTP in a later video and make sure that we get the clocks set on all of our devices. What else can we do? Can we do a show run? No, we can't do a show run. Can we do a show start? No, we can't do a show start. See, so it is very limited what we can do in user exec mode. If I type show privilege, no, very little we can do in this mode. Using the question mark again though, we can see that one of the things that we can do is we can type enable. Now enable, that's dropped us into privileged exec mode. In privileged exec mode we can do an awful lot. So there should be a password, one to stop us getting into the router at all. We'll put that locally on the console port, and there should be another one to stop us getting into privileged exec mode. Okay, let's just try a little command again, show privilege. Okay, we are currently at privilege level 15. This is as high as it goes. In privileged exec mode we can do pretty much anything that we want to do. User exec mode is privilege level 1, and we can't do very much whatsoever. Okay, what we're going to do now is we're going to go into global configuration mode, and we'll put a password on the console port, and we'll just do a very basic setup first of all. So I'm going to say password. No, I'm not. I'm going to get into the line console first. So line console 0. There is only one console port on the router, so it's console port 0, and we're going to type password and then just type a password in, which I'll make Cisco. Not a good password. 1, it's short. 2, it's only got lowercase letters. And 3, it's a dictionary word. So we've broken 3 rules already. And then I'm going to type login. Okay. I'm going to type Control Z. Brings me all the way back to privileged exec mode, and then LO for logout. Now when I hit enter, now we see a difference. I've been asked for a password, which is the console password of Cisco. Now this isn't very good. What we need to do is we need to do a better job than that. So I'm going to do Conf T. I'm going to go back into the line console. I can shorten this to line con 0. And I'm going to remove the password. No password Cisco. Okay. I'm going to type exit just to bring us back 1 level to global configuration mode, and I'm going to set up a minimum password length. Okay. How do we set up a minimum password length? Not so obvious, but it's actually security. Just trying to put the tab in at the moment. Security passwords. Notice the use of the question mark. What follows security passwords? Min length. On a Cisco router, the question mark is your friend, especially in any kind of practical work that you're doing. So security password minimum length, and we can have a minimum length of between 0, which seems a bit crazy to a certain degree, and 16. Okay. I'm going to put security password minimum length 8. Let's just try something now. I'm going to go back into the line console. Line console 0. I'm going to try to apply a password of Cisco again. There you go. It's enforcing our password minimum length. Why do we want to have a long password? It makes breaking the password considerably harder. Every time you add extra digits or characters or letters, you increase the complexity of the password and the job that the password cracking software has to do significantly. Okay, so let's see, what can we do now? Let's try configuring not just a password on the console, but we will configure a username and a password. It's obviously better to have a username and a password on the console. So to do that, we will type in username, Kevin, okay, and password, Cisco. Now that's obviously not going to work, is it? Too short. So we'll use a longer password of, I don't know, December. Is that long enough? That looks long enough to me. Yep, 9 characters. No, hold on. 8 characters. That's spot on. Okay, so now what have I done? I've created a user, a local user on the system with a username of Kevin and a password of December. Okay, so if I log out now, Control Z, LO to log out, log back in again, it lets me straight in. What's going on? I've created a user, I've created a password. Why is it not asking me for that password? Well, I haven't done the second step. I must remember to tell it when somebody logs into the console port to actually ask for that password and username. So we go back into the line console 0, and we say login followed by local. In other words, we're going to use the locally created username and password for the login information. Alright, let's try again. Control Z, LO to log out, and look, big difference. Username Kevin, password December. Notice when I type the password it doesn't show. Obviously it doesn't show the password, but it doesn't even show little asterisks for each of the characters in the password. Security feature, somebody's looking over your shoulder, they can see that your password is only 8 characters long, gives them information. They don't need to set their password cracking software to more than 8 characters. Okay, so we're now getting somewhere. But, problem. We can still get into enable mode or privileged exec mode without a password. We'll need to do something about that in a minute. And another problem too. If I type show running config, which I can shorten slightly, sh running config, and I have a look at our running configuration, we can see a new command in there, security password minimum length 8. We can see the locally created username Kevin, with a password December. 0 means the password that follows is not encrypted, and that's not good, is it? If I run show running config, and we have that character looking over her shoulder again, they're going to see our password. Okay, so what are we going to do about that? We need to fix that. Okay, so we'll get onto that in a moment. Let's put a stronger password on. How can we do that? Conf t, we'll create another user, username Bob. Bob has a slightly better idea of what he's doing, so Bob is not going to create a password, but Bob is going to create a secret password, and this will be November. Okay, Control Z, show running config, and we look down the screen. Notice November. Obviously that doesn't look anything like November. That is a secret password, and that is using a very strong encryption algorithm. That is not easy to break at all. Okay, so anybody looking over a shoulder would have absolutely no clue, and that is also quite a difficult password to break because of the strength of the encryption algorithm. Okay, so I'm going to hit Control C to stop going through any more of the running config. I'm going to do a log out, and I'm going to log back in again, only this time I'm going to log in as Bob with his password of November. There we go. And we log straight back into, which mode is that? That's user exec mode. Right. Let's put a password on getting into privileged exec mode. How do we do that? Well, first of all, we need to get into privileged exec mode so as we can access global configuration mode. So enable conf t. We can type enable password. Now I need to think of something that's nice and long. So what's another September? I'm going to forget all of these months. September. Okay, enable password of September, and let's try see what else we've got. We've got enable password. We've also got enable secret, and this one we'll just type Cisco twice. Okay. What's the difference? Enable password and enable secret. Well, I'll do a Control Z. Well, let's have a look. Show run. That's the difference then. Your enable password appears in clear text, whilst your enable secret again uses that very strong encryption, and it's much harder to work out what's going on there. Okay, so really what we should be doing is we should not be using enable password, we should be using enable secret. Now there is a little trick. There's a little trick that will encrypt all of the passwords on your router or switch that are not already encrypted. It won't re-encrypt the strong encryption passwords, but it will encrypt all of the passwords that are not already encrypted. And that command is service password encryption. Okay, service password encryption doesn't look like it's done very much, but if we look at the show running config, there we go. Now, which one of these is stronger? The level 7, which just uses uppercase letters and numbers, or the level 5? Obviously the level 5 is much stronger. We've got special characters appearing in there. We've got uppercase and lowercase letters. It's actually longer anyway. Now, how weak is that? Well, put it this way, if I was looking over my shoulder, I'd have a little bit of a problem trying to work out precisely what that is. I mean, it's not something you can actually do in your head, but also it's not particularly strong either, and I'll show you that just quickly. I'm going to copy the level 7 encrypted password, and I'm going to just very quickly go into the internet, go to Google, type Cisco level 7 password. And what have we got? How about this one? Cisco Type 7 Reverser. Packetlife.net. Very useful website. Excellent stuff on the Packetlife.net website. Brilliant cheat sheets. Well worth checking out. Okay, and we'll paste that level 7 password into a web app. And there you go. As quick as that. Your password is September. Hence, it's only really useful for stopping people looking over your shoulder. Right. Now, Control-C, jump out of running config nice and quickly. And where do we want to go from here? Well, let's have a little look at something else. There's another neat little trick you can do. Let's create another user. Conf-T. Username. Oh, I don't know. Who should we call this one? Joe. Joe's the administrator. And Joe will have a privilege level. There we go. Of 15. What's the privilege level of 15? That's privileged exec mode. And we will put in a secret password of network 4321. Still not a great password, of course, because it's based on a dictionary word. So network 4321, but at least it's a secret password, so it will show up encrypted in the running configuration. What's this privilege level 15? Okay, let's have a look. Control Z, log out, log back in, username, Joe, network administrator, enter. Password. What did I just make Joe's password? It's a good job I've still got it in the buffer. Network 4321. Remember, network 4321. Network 4321. Ah. Look at this. Instantly, on login, straight into privilege mode. Show. Privilege. Privilege level 15 access. I didn't need to type enable and tap in my enable secret or my enable password. Instantly on login, I get privilege level 15 access. Okay, that's quite nice. Could be dangerous in the wrong hands, but for the network administrator with a nice strong password that he changes on a regular basis, shouldn't be a problem. Okay, of course, there are more than privilege level 1 and privilege level 15. We've in fact got 16 privilege levels. They range from 0 all the way up to 15. So we could actually set a custom privilege level. Let's see if we can do this in Packet Tracer. Conf-T, username, pool, privilege, look at that, 0 to 15. Let's give him a privilege of 3 and give him a secret password, which you have to spell correctly. A secret password of, oh, I don't want another one that I'm going to forget, so let's just do Cisco followed by Cisco followed by Cisco. Right, Cisco, Cisco, Cisco. Right, now he has a special privilege level, a custom privilege level, level 3. Let's say what he can do on that level. So, privilege, exec level. So for privileged exec level 3, what are you allowed to do? You're allowed to, I know, show the startup configuration. The full command is show startup config. Okay, now normally with level 1 access you can't do that. Okay, let's have a little look. Paul, Cisco. Paul, Cisco. Now looking at this, you would think we're actually in privileged exec mode. Let's have a little look. Show privilege, but we're not. Privileged exec mode is level 15. We're currently on level 3. Show running config. We can't do show running config. That proves the fact. If we were really in privileged exec level 15 access, we would be able to run pretty much any command we wanted to run, but we can't run show running config. Let's try show startup config. No problem at all. There you go. We can run show startup config, but we can't run show running config. So I'm going to do hello to log out, and I'm going to log back in. Oh, what was that? Network, wasn't it? Good grief. I'm going to need to write these down. That's the worst thing you possibly could do, is write down passwords. Right, we haven't got him. It's not in the buffer. Now we've got a problem. Joe. That was it. It's so easy to forget passwords. That is the other thing. Network 4321. Okay. One thing you can do is, rather than making the password a strange combination of letters, you can kind of make a phrase, and the password could perhaps be the first letter of each word in the phrase, or things like that. There are ways and means of trying to remember these things. Okay, so we're now back in the router. If we do a show run, because I'm full privilege 15 access, Joe has full privilege 15 access, he can run any command he likes. Wow, there's a few users on there. Some users with weak level 7 access, most users with strong access. MD5. Okay. Right. I don't want this particular video to go on forever, so we'll carry on going now, and we'll have a quick look at exec timeout. So what's the exec timeout? If we go into the line console, configure terminal, line console 0, we can set an exec timeout of, in minutes and seconds. The first number is minutes, the second number is seconds. Let's say 1 minute 30 seconds. Okay. Now if we don't do anything for 1 minute and 30 seconds, and we're logged in through the console port, so we're locally connected using a rollover or console cable off of a laptop, for instance, through the console port, and we leave the terminal completely alone for 1 minute and 30 seconds, it will log us out. Very important. The last thing you want to do is to go through all of your strong passwords and then leave yourself logged in while you go away and make yourself a sandwich or a cup of tea. Somebody can come along and go, oh look, they left the system logged in, and cause all kinds of havoc. So 1 minute and 30 seconds of inactivity will literally log us out of the router. Okay, so that's your exec timeout. Not only do we want to do an exec timeout, but we also want to create a login block. And what does a login block do? Well, a login block will block people from being able to access or log into the router if they make a certain number of bad attempts in a certain period of time. So for instance, what we're going to do is we're going to block logins to the router for 120 seconds, 2 minutes. If 5 bad attempts are made within 30 seconds. Now actually 30 seconds, 5 bad attempts, I'm going to have to log in relatively quickly, but if I do that I would literally log myself completely out of the router. Okay, and there you go, there's the timeout, 1 minute and 30 seconds, and away we go, it's automatically logged us out. So that was our exec timeout 1 space 30. And now we have to log back in again. Okay, so Joe and network 4321. What privilege level are we? Show privilege level 15. Okay, let's try this. It's a configuration, so we need to get in configuration mode. Conf T, and we're going to type in login block for question mark time in seconds. We'll block for 120 seconds, 2 minutes. If 5 bad attempts are made within, I don't know, let's make it 45 seconds just to make it a little easier. Okay. Bum, 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 bum. Now I'm not going to test this because I don't really want to sit here waiting for 2 minutes. But if I logged out and I tried to log in as Joe, for instance, and couldn't remember his password of network 4321, and I entered 5 bad passwords within 45 seconds, it would literally block further logins for 2 minutes. This is a very good approach to stop brute force type attacks or dictionary attacks, where the computer's literally just logging in hundreds or maybe even thousands of times a second. Okay, let's create a banner. How do we create a banner? Banner. What type of banners can we create? We can create a login banner or a message of the day banner. They're both done in a similar way. I'm going to create a message of the day banner. We type banner, MOTD, and then we need what's known as a delimiting character. Now this must be something that does not appear in the text of your banner, because anything that is between the 2 delimiting characters is the banner. So if the delimiting character appears in the text of your banner, you've got a big problem, because you'll only see part of the banner. Let's see if I can explain what's happening. Do not attempt to log in. Now, if I put and access this router, and then put my final delimiting character, I've got a problem there, because what's going to actually happen is it's going to look in between the 2 ampersands. This first delimiting character here, directly after the MOTD word, is the delimiting character, and it will be anything, the banner will be anything between the 2 delimiting characters. So all we'll get is do not attempt to log in. It will miss this part altogether. So what I need to do is I need to make sure that I don't put my delimiting character in the banner. So do not attempt to log in and access this router. Almost certainly not the best banner in the world. I'm sure you can think of a much safer banner. The one thing you don't want to say in a banner, of course, is welcome to my network, because if you take somebody to court for breaking into your network and you have a banner on there that says welcome to my network, I think the lawyers could probably argue that you maybe invited them in. Okay, so banner MOTD, delimiting character, do not attempt to log in and access this router, end delimiting character, enter. Let's try that. Control Z. Hello. To log out, and we log in, and there we go. A banner. Do not attempt to log into this router. Unless you're authorized to do so, probably would be a good idea to add to that. So Joe, network 4321. Okay, we're looking good. Excellent. Let's quickly set up Telnet access. Conf T, Telnet. We need to go into the line VTY There are 15 VTY lines, 15 lines to Telnet into this device. We'll just use the first the first 5. So line VTY 0 space 4. So that's VTY lines 0, 1, 2, 3 and 4. The first 5 VTY lines. And we'll say, well, we could say password and then create a password. Cisco. That's not long enough, of course, but I'm not going to bother doing that. We've already got usernames and passwords on this system. So why don't we use the local usernames and passwords excuse me, that we've already created? I'm going to type login local. Use the local usernames and passwords. Excellent. Okay. Let's give that a test. Excuse me. Let's see what IP addresses we have. Show IP interface brief. Okay, we'll come in from the laptop, and the laptop is in VLAN 10 sales. So we'll try to access this IP address here, 172.16.10.254, and see what happens. Command prompt, telnet 172.16.10.254. And we can see a message of the day banner. Do not attempt to log in and access this router. We'll log in as Joe. Network 4321. And we're in. And we're in with privilege level 15. Okay. Now there's a big problem with Telnet, because when we logged in, packets were sent from a laptop to the router using Telnet protocol, and the Telnet protocol is clear text. So as we were logging in, those Telnet packets were literally carrying ASCII characters in clear text. So anybody using a protocol analyzer like Wireshark, for instance, able to sniff access to the network. Very easy if you're using a hub, slightly more difficult if you're using a switch, because you have to poison the ARP cache on the switch. But if somebody using a protocol analyzer like Wireshark sniffs the traffic and you log in using Telnet, the game's over, because Telnet is clear text. So we don't want to use Telnet. I'm just going to log out, and what we'll do is we'll set up SSH access. So back into the router. It's logged us out because 1 minute and 30 seconds have passed, so our exec timeout's definitely working. Whoa! Careful, careful. Right. Joe. Password. Network 4321. Excellent. And we're back into the router. Now to configure SSH, there's a couple of things you really need to know. One is you cannot use the router's default hostname. A router's default hostname is router. Switch's default hostname is switch. You need to have a non-default hostname. Well, we're okay. We have R1. So we've changed the hostname to R1. It's a non-default hostname. That's good. But we also need to have an IP domain name. So, let's see. conft IP domain name. I'll use my little company, remote training. Actually, there's no hyphen in it. Here we go again. Remote training solutions. Oh dear. Okay. Will it accept that? No. Why will it not accept that? Because the spaces. Can't have spaces in the domain name. So what we'll do is we'll take it back and we'll say remote training solutions. Okay, I'll accept that. No problem. Okay, I mean we probably could have got away with using hyphens or possibly underscores. It's something I just need to have a little look at. But we now have a domain name. And the way SSH works, it creates two keys. It creates a public key and a private key. And these keys are related to each other. and they're actually based upon, among other things, your host name and your IP domain name. Okay, so this is why we need a non-standard IP domain name. Well, we need to create a IP domain name, and we need to use a non-standard host name. So here we go. SSH crypto key generate. Actually, I think that will probably do. Let's have a look. RSA. Crypto key generate RSA. RSA is Rivest, Shamir and Aldelman. Three guys who did a huge amount of work on the private public key encryption techniques. So, boom. Okay, the name for this key, this is why we needed the non-default host name and an IP domain name. Okay, because it's using that as part of the process for the keys. And we want to set the size. This is the modulus. So the modulus, let's just set it to 2048 bits. That's extremely strong encryption. Okay. Now that did that very quickly. On a real router it probably wouldn't be quite as fast as that, unless it was a fairly new router. That's quite a job to create those keys computationally, but modern processors could do that relatively quick. Okay, SSH has now been enabled. Now the problem is, yes, SSH has been enabled. We have usernames, we have passwords, but we need to make sure that the VTY lines use SSH. So if we have a look at the VTY lines, they probably, I don't know whether you can see this in the running config, but we'll have a look. I don't think you can because it's a default. Interesting thing is defaults don't generally show up in the running config. So if we bounce down to the bottom by hitting the spacebar, let's have a little look. Line VTY, login local. No, it doesn't show up. We need to tell it that the transport input has to be set to SSH. Currently the transport input is set to Telnet, which is a default, so it doesn't show up. So configure terminal, we go into the line VTY04, and we tell it that the transport input is for input connections to the router, packets coming into the router on the VTY lines, has to be set to, we've got all, none, SSH and Telnet. I'm just going to set it to SSH. Okay, transport input SSH. Now that will have stopped Telnet from working, I'm presuming, so we'll give that a test. We'll use the up arrow. There you go, look at that. That was working before. We were actually getting in. Now we can't get in. Try again. No, not playing. The transport input is now set to SSH, not Telnet, so we cannot get in. How do we SSH? From a host. SSH, I think it's -L for login, Joe, and then the IP address. Right, this may or may not work. Let's give it a try. 172.16.10.254. Oh, look at that. And Joe's password is network 4321. And there's our message of the day banner. And we're logged in. We're logged in remotely, only this time we're logged in remotely using SSH, which is a very much stronger encryption mechanism than, well, Telnet has no encryption mechanism, it's clear text, but SSH is extremely strong encryption. Okay, this is good. So we can remotely manage our router using an encrypted protocol. Fantastic for security. Next, we've only got one more thing to look at. This is not on the router, this is on the switch. What I'm going to do, I'm just going to do a WR to make sure I don't lose any of my configuration. And we're going to pop down and have a little look at the switches. Okay, so I'm going to open the switch. I'm going to open the first switch, SW1, switch for the PCs in the sales VLAN, VLAN 10. I'm going to go into the command line. I'm going to set up what's known as switchport port security. So we'll do an enable. We'll do a conft. Now currently, at the moment, we have fast Ethernet 01 going down to the wired host here. We have fast Ethernet 02 going off to the access point. I'm going to use fast Ethernet 03. And we'll set switch port security up. Okay. First things first, I'd like to look at the running config. But if I type show run, because I'm in configuration mode, it doesn't like it. What I can do though is I can go to the start of the line and type do show run. Do allows you to run pretty much any command from any mode. Okay, I'm just going to pan down and have a quick look at fast Ethernet 03. It's in VLAN 10. It's an access port, not a trunk port, and it's in VLAN 10. That's looking good. Okay, so interface fast Ethernet 03. First of all, we'll switch on switch port security. So switch port security. This enables port security. Port security is very clever. You watch this. This is very, very, very smart indeed. Okay, so switch port security, question mark. MAC address. Now we could configure a MAC address manually now if we knew the MAC address of the device that we want to connect to port 3. We would literally just type the MAC address in here. Okay, but we can do better than that. Well, potentially save us a little bit of trouble. The device is not connected to port fast Ethernet 03 at the moment. If we type sticky, what it will do is it will register automatically the MAC address of the first device connected to port 3. Okay. Now I'm going to use the up arrow to repeat the previous command, and we'll set the violation. So switch port, we have a violation, and I'm actually going to set the violation to shutdown. Now, to be honest, that's the default. But the violation modes, you have shutdown. In shutdown mode, it will generate a violation alert and disable the port. The only way to re-enable the port is to actually manually enter no shutdown on the port. So I generally do a shutdown and a no shutdown just to be safe, and that will bring the port back up, providing the device, the rogue device, is still been disconnected from the port. We have restrict mode. In restrict mode, frames from non-allowed addresses, they would actually be dropped. In this mode, the switch will make a log entry and it will generate a security alert violation, but it simply drops the frames. And you've also got protect mode, and in protect mode, frames from non-allowed addresses will again be dropped, just like restrict mode, but it will not make a log entry for the dropped frames. The interface will just carry on learning addresses until it's reached the maximum number of addresses that you set. Any additional learnt addresses will be dropped, but still keeping the interface fully operational. So I mean, the safest way of doing it is to put it into shutdown mode. This means if somebody plugs in a rogue device with an unknown MAC address, it will shut the port down. Okay. Right, so switch port security, violation, shutdown. Excellent. Bang. We better set the maximum MAC address number while we're here. So switch port security, maximum, and we can have between 1 and 132 MAC addresses. I'm actually going to set it to 1. Okay. So if we do a show run now, and we have a little look at the running configuration, we can see that switch port security is enabled for fast Ethernet 03, and we've got MAC address sticky, so it will learn the MAC address of the first device plugged in. Let's go for this. I'm going to grab a PC, drop it on the board. I'm going to grab a straight through cable, copper straight through, connect it into fast Ethernet 0, and then connect it into fast Ethernet 03 on the PC. Now probably what I could have done with doing on that port is to enable spanning tree port fast, because I'm going to have to wait a few seconds now whilst the port checks to make sure there are no bridging loops at layer 2 and the port comes up. When the port does come up, when this light goes green, we should be able to get an IP address using DHCP on the PC. And of course the port will only register one MAC address, the MAC address of this PC, and that will cause no trouble. So the PC is now up, the port is up, the PC has no MAC address, no IP address. Of course it does have a MAC address. In fact, we can see the MAC address. It is 001C72888D3. I'm going to just go to desktop and tell it to get a DHCP IP address. Excellent. It's got 10.3, which makes sense because the other PC, the other wired PC, has 10.1. The wireless has 10.2. This has now got 10.3, and all is good in the world. Okay. Now, this PC is your legitimate customer. Now somebody comes in while this desk cubicle is unoccupied, removes the network cable from the legitimate customer and plugs in their own device. Let's pull up another PC which will have another MAC address, and what we will do is we will just unplug the network cable from that PC and plug it into the rogue PC. Okay. Now it's interesting because of spanning tree, we've got the port in blocking mode at the moment whilst it checks to see if there are any bridging loops. While that's doing that, just very quickly look in the router. Exec timeouts logged us out. So Joe network 4321. Actually, it's not the router I want to look in, is it? It's the switch. Look into the switch. Show run. No passwords on the switch at the moment. Hehe, looky here. Switch port, port security, MAC address sticky. It's registered the MAC address of the legitimate PC. Watch what happens on the rogue PC. As soon as it sends a packet into that port, we'll do that by asking it to get DHCP IP address. Bang. Requesting IP address. Well, that's going to fail because you can see instantly the port's gone down. Switchport port security has registered the MAC address, which is not the correct MAC address. It's not the MAC address that was remembered by the sticky command. So it shut the port down. The fact that the port has shut down has meant that it cannot, this PC cannot reach the DHCP server running on the router. Now the PC is trying to get an IP address using DHCP. It cannot reach the DHCP server configured on the router. So it's now got what's known as an APIPA address, an automatic private IP address. 169.254 anything basically. So the first two octets are 169.254. So 169.254 and a /16 Microsoft APIPA address, automatic private IP addressing, generates a random IP address in that range. It's got a technique that it uses to make sure that there's no duplicate addresses. It's basically what happens if you have automatic IP addressing, obtain an IP address from a DHCP server enabled, and you can't contact your DHCP server. Okay, looking good. Let's go in the switch, and we can see there's been a shutdown event. Okay, do a show run again. Can't see anything on here. We can just see the legitimate MAC address of the legitimate client, but we can't see anything else. Okay, so what we do is, let's have a look. Show. Let's see, what have we got? Do we have show switchport port security? No, that's probably not even a legitimate command. Let's go into the interface. Show interface fast Ethernet 03. What have we got? Switch port. Oh, let's have a look. What have we got? It is currently down. It's in the sales VLAN, VLAN 10. Can't see anything on there. Show port security. There it is. Okay. Show port security. Show port security. We have a port security violation on Fast Ethernet 03. Maximum number of IP addresses 1. The current IP address is 1. We have a security violation and the port is now shut down. Okay. How do we bring that port back up again? Well, we first of all need to disconnect this PC. So what we're going to do is I'm just going to actually take that PC out altogether. Goodbye PC. Okay, so our network administrator's turned up, removed the PC and the person who brought the PC in, deposited them in the local jail, and now what we'll do is we will connect the correct PC to Fast Ethernet 03. Notice the port still doesn't come up. So your network administrator now needs to go into port Fast Ethernet 03, interface Fast Ethernet 03, and they need to type, well actually what I tend to do, I don't know whether you really need to do no shutdown, but I'm just being a, well, shutdown, no shutdown, but Fast Ethernet 03, that's correct. Shutdown, followed by no shutdown, that's it, great. Oh. So we had to go into the Fast Ethernet interface, type shutdown to administratively shut the interface down, followed by no shutdown to bring it back up again. And at that point, the port's working again. Now, of course, the great thing with this is the rogue user wouldn't be able to fix things. In fact, if the rogue user thought, oh dear, what's happened? I've been caught, they might plug their PC out, remove the cable from their PC and plug back in the cable to their original PC. But that's not going to help much either, because the port still won't come up until the network administrator's gone into that port manually and done a shutdown and a no shutdown. Okay, well this has been rather a long video on security, but we have covered quite a lot of things. I will do a later video on more advanced security techniques. What I'm going to do, just very quickly, I'm going to do a WR on the router, just to make sure everything's safe. I'll log in as Joe. Network 4321, and I'll do a WR on the router as well. Okay, so what have we been covering? We've covered a lot. We've covered minimums, password security length. We've covered passwords, standard passwords on the console port. We've covered usernames and passwords. We've covered privilege levels. We've covered service password encryption, which will encrypt any passwords that are not already encrypted. We've covered exec timeouts, login blocks, message of the day banners, Telnet and SSH access, and finally switchport port security. And that is nearly coming up to 54 minutes for this video, which I think is more than enough. Okay, so video 5, signing out. Please return for video 6, where we'll look at more advanced security. Only that will be a slightly shorter video than this one, because we've covered so much in this first security video. I hope this has been useful to you. Thanks very much for watching, and please return for video 6.